So hello, everyone. I am Cavell's Network and Security Analyst. Some of you will already know me, some of you won't. I'm the analyst they bring in to broaden out the agenda a bit. You know, when they've been talking about cloud comms for like 6 or 7 hours, they're like, all right, let's bring Finbarr on. He can talk about networks. And obviously, some of you will have network businesses, others of you don't. So this is kind of a higher level presentation trying to get everyone engaged in networking as a topic rather than drilling too far down into specifics about SD-WAN technologies like that. So obviously, if you want to talk about those in detail, you can just come and chat to me. So today we're going to cover, pretty briefly, current state of business networks. This is a topic thing. We've got a lot of time. Well, we've got 20 minutes to get through all of this. An idea of where future network demands and where those things take us. The idea of what we need in a future network, robustness, scalability. What then does the network of the future look like from a principles perspective? What are we trying to actually solve at each and every level of it? Impending challenges, and thank you to the end of the last panel, AI. How does the AI interact with the network, and what are the problems that are being created by AI in the networking field? And then, of course, some takeaways to keep us all happy and give us some things to think about. So let's start with some data and some graphs. So Cavell does our enterprise research every year. One part of that is the networking research, where we go to network managers and we ask them, what are you doing and how are you doing it? You'll see quite a few people using a mix of services. This is a 250 plus employees, so slightly larger companies. Lots of fiber, but still only about 50% of people using business fiber for their company, even at that level. A lot of people still using broadband and using consumer fiber, fitting in a bit of cellular there. Still a good mix of MPLS, IPVN, SD-WAN. SD-WAN continuing to grow. Some of the budget for SD-WAN is being siphoned off and put towards security and secure access instead, but the technology is continuing to grow. It is the next generation of networking, and people will continue to invest in it because it's just better and smarter than the thing they were doing before. Other thing to note, just on the side, is that when you're talking about companies of this size, you are talking about a network that is more diverse. A lot of these companies, around 70%, said, yes, I have sites outside my home market. Now, for companies in Europe, that could be outside the EU, or it could be their neighboring countries. There's a lot of definitions of what home market is to companies. But this idea is that I don't just have sites in my region. Most of these companies, even at this size, have at least an office or something they have to connect outside their home market. And obviously, if you're providing an access network, that creates problems and challenges for you. So let's play the quick game, which is always fun. How many people have heard of the following? I'm not going to ask a poll, but I'm just going to say the words. So first we have IoT, that thing that keeps getting promised. And some businesses definitely, of course, are using it. Agriculture, factories, those kind of things. Then we have AI and automation. Everyone's heard of that. That's fine, I'm pretty sure. And then, of course, we have the data-driven business, which is probably something some people are familiar with. But the idea is we're going to gather up all the data about everything my company is doing. We're going to feed it into various analytics engines, and we're going to talk about productivity, what happens. Now, what do these things have in common from a network perspective? They generate a large amount of data. They have variable speed and latency requirements. Some of these things are urgent. I need real-time information on what's happening in my factory so that if something goes wrong, I can fix it immediately when it goes wrong, right? Some things don't need that. Some things you can come back to the next day and say, okay, I'm happy to review this at a later date. That's kind of important. And they also have a huge reliance on cloud processing power to deliver services. I don't know of any of these things that does not rely on a large amount of cloud processing power to actually deliver the AI, the machine learning, the IoT management, all that data-driven business. You're taking all that data, you're sending it to the cloud, and the cloud is sending you something back. So this brings us to an interesting discussion as to what the future demands are on a network, which as service providers you obviously have to be aware of, because this is the environment that your platform is playing in. We have future network demands scaling faster than you've ever seen. We obviously have more competition for bandwidth during peak operation times. Now, we're going to come back to this a few times during this presentation, but if all of these AI and ML systems are all happening, what's the one thing that's fueling those? It's data. It's data sent from my network to a cloud platform. Now, at the moment where that's just language, text-based data, maybe that's not a huge amount of bandwidth. But the second you start adding in video, photos, unstructured data, all of these kind of things, the amount of bandwidth required to do any sort of AI or ML processing in a large scale becomes rapidly accelerated. That, of course, creates an increased network management burden. There are more devices being added in, both user, employee devices, IoT devices being added in. And you have to somehow, in all of this, create a seamless system that also provides security and protects your network. So all of this kind of ties back to one idea, which I want everyone to take away, is this idea of network-aware applications. So that is applications that are both aware of the pressures they are putting on the network and also aware of the pressures that the network is currently under. So what that looks like is the idea that if I'm making a big demand of a network, so I've got an AI process in my computer, in my solution, and I'm about to, say, send a huge piece of information that I need to transit over the network. Should I tell the network that that's coming, in the next hour, 2 hours? Because I know the users generated it, I know they're working on a project, and I know that that network bandwidth demand is coming up. So what do I do about that? How does the network know the pressures it's going to happen? And what happens when two of those things collide? Which one is more important? That's kind of an interesting question. If two big tasks of processing bandwidth come, and you're at a company that doesn't have a huge amount of bandwidth on that site, which one takes precedence? And how are the applications talking to each other to decide which is the most important, and talking to the network as well? So that brings us up to this idea of a robust, scalable network. So this is just an idea I put together. I might have never use it again, to be honest, because acronyms are come and go, but I think it captures what I'm trying to say. So in the future, we need to get to the point where a network is a robust, scalable network. Now, what does that mean? The robustness means the network has to be capable of healing itself, being centrally managed. It needs to provide a high visibility of operations, have automation and smart networking capabilities, and of course, strong security to make sure it's actually protecting itself and your users. It has to be scalable. We're talking about networks that are becoming more and more complex. They're connecting to more cloud services, they're connecting more devices, they're connecting and providing input on your devices that aren't even on your network. I was talking to a vendor the other day who was telling me about their new protocol for implementing off-device IoT and employee phones into their network management system, so we can figure out, how these devices are operating even when they're not on the network and on the business network. And then, of course, we've got the network, which is the easiest one. It's just the idea that it's going to connect everything, not even the devices that are on your business network, but also the devices that are on the public network, and provide you input on what those are doing and let you have policy control over how they're operating, which is very relevant for things like IoT, because if you have a container that's moving from port to port to port on a ship, it's going to go from port network to cellular network, global network, and that IoT device needs to track itself, understand where it's going, so it can never be lost, and you don't lose that container and lose everything in it. It also is important to understand that the future of the network is a network that understands the requirements of every solution operating on it and how they need to be treated differently. And I'm going to say that a bit because I think that's kind of the most important thing, is that a lot of what we're talking about, when we talk about the future of the network, is how applications and the network share data with each other to enable better control and understanding of the two systems and how they work together. So this brings us to my next slide, which is a Venn diagram. I'm sure people will take a few photos of it to digest it later on. But the idea is that in the future, we've got these three main areas of the network, and you can slap private in front of any of them or public in front of any of them. That would kind of work. Or imagine that the home is kind of a cafe or something like that. But really, we're talking about three main principles, right, that the network needs to adhere to in the future. Good user experience, an efficient service, and a secure service. And once those three things are done, everything else is just about where are you accessing from. And that becomes less and less important as long as those three things are taken care of. So the main things when you're accessing the network from the home is that security has to almost come first, because someone is exposed at the edge of the network outside your private, corporate network. And where are they going? How are they accessing? How do you know that that person is actually accessing from their home? How do you know they are who they say they are? How do you verify that person is accessing from their house and is secure? Same with remote workers. If someone's accessing from a cafe, how do you verify that person is really who they say they are and where they're accessing from? How secure is that network that they are accessing from? They also need to have support without complexity. That's the biggest thing, really, is that I'm providing you a network service. It needs to work. It needs to tell me what's wrong so I can fix it, but the end user doesn't need complexity on their network. And then also you need some sort of quality access to cloud services. A lot of what's being built now are ways for users to go directly over the internet to their cloud provider and essentially get a much more direct access line so that their services work better. On the business side, we've got productivity, of course, freedom of movement within an office, so people can pick up and move to different parts, and also the idea that the network needs to track where in your office is the most congested, so that if everyone is gathering in one room and it's always slowing down, that's a piece of productivity information that needs to come back and feed back in. And of course, things like direct access to cloud services, application prioritization. And when we're thinking about the cloud, really the main takeaway is the idea of integration. When you've got two cloud services that are working together for the same customer, and they're both sharing the same networks and things like that to deliver services to the customer, there is an idea that there should be some sort of cooperation there. There's an understanding of how they're both using the same network and how much data they're sending down that pipe to the customer, so that you can understand the best way to use the network to provide both services together. So the idea that you've got this big data center in the cloud gets lost is kind of needs to step away so that people can actually understand the impact of the data they're using. So to step back from looking at what the idea of this future network is into the present, and just ask a question, which is again from our enterprise research, about how satisfied people actually are with their current network. And the answer is kind of. So these are 250 plus employee companies across the US and EU, and about 50% of them are satisfied with their, network, and the same with their network provider. But if we're in a situation where there's actually quite a lot of room for improvement, if only half of the market says they're happy with their provider and with their network, we have to ask that if I'm predicting in the next 5 years that there might be more problems on your customers' networks than there is now, how much do these numbers change? Because if you had a bit more of a buffer, if you had 90% satisfaction, they might accept a couple years of disruption without actually getting too dissatisfied with their provider. But networking and access customers are actually quite fickle, and they will change if their quality of their network isn't good. So if they start moving their processes forward and the network doesn't follow them, then you have problems. So this kind of leads us on to a big prediction that I have, which has kind of been coming through this entire presentation, which is that actually we might be on the cusp of a bandwidth crunch at some companies. Now, this isn't talking about the largest of companies who can pay for whatever they want, or even someone who's in the middle of the city and has connections to every fiber line you can imagine. But there's plenty of offices that don't fit that bill, and I think most of those are represented in earlier slides where we see the big mix of connectivity options that companies have. So we've got this potential rise in AI and machine learning processes, which require a large amount of bandwidth. We have a rise in energy costs and awareness of the actual impact of the cloud on energy grids, which I think is also something that is underestimated by a lot of people, is the actual energy cost of the network. I had a meeting with a large UK service provider who told me that through a switch, he saved 95% of his network energy costs by changing just a few things at the company switching providers. And you're talking about not a small amount of electricity, which is not a small amount of money these days. So here's a question, and I guess a scenario. We're talking about your customers bringing in an AI ML process. That takes up a certain amount of cloud processing power. It takes up a certain amount of network data, right? Now you're saying to them, okay, to do everything you want to do at the exact second you want to do it, this is your bandwidth requirement. It's 10 gigabytes or whatever, maybe more. This is how much it's going to cost to keep that network uptime 100% on an ongoing basis. So the question then becomes a question of prioritization. How much of your actual activity with this new AI platform needs to be done immediately? And how much of it can be done overnight, the next day? So here's a question. On a consumer level, we use tariff pricing based on times that energy is being used. As networks and processes get smarter, as they talk more about how important tasks are, when will customers start asking for the same thing from network providers? When will tasks start being shifted so that things that aren't actually that important for you to do right now during the day get sent off overnight when the network, and conversely, the electricity consumption of the network is not as high? So we're talking about an impending bandwidth crunch, but we're also building the tools to prioritize and understand how important different tasks are during the day and the workflow, so that we can potentially economize how we actually use the network, so that the most critical functions happen when they're needed, and other things maybe don't happen at the same time. There's also broader trends in terms of, more services moving to the cloud. Everyone kind of expects that. There's more consumption by IoT devices. One of the great things about 5G coming in is that people are taking advantage of those increased speeds to give new applications and bandwidth draws to consumer applications. And of course, that does feed into the workplace because everyone brings their phone in and is using it in their breaks and stuff like that. So there's general things just leading to this idea that bandwidth is not unlimited at a lot of companies, and more of it can also be quite expensive. And we have all of these new processes coming in, but we need to sort of understand how that's going to impact the network. Relevant, of course, to service providers and UCaaS providers, because your platforms are competing with all of these services for bandwidth during the day. And I mean, everyone, I think, would be much more relieved if all of these backups, processing, all those kind of things was all set to happen in the evening so that your UCaaS platform could happen during the day and have free reign over the network, right? That makes everything much more comfortable. So just to talk about AI for a second, because I think this is quite interesting, because AI is necessary for the future of networking, and thankfully, a lot of providers, VMware, Cisco, and Mist from Juniper, are already starting to work on, I would say, quite robust AI platforms that are actually bringing these kind of benefits through. For example, the Juniper platform, you can ask it in plain text, what issues did I have overnight, and it will give you a list of specific things that happened. Or even, example, if you're working in a school district, and this is a customer of theirs I spoke to, and someone loses their phone, you can say, well, where is the iPhone with this name? And it'll track it down to a specific access point. And you just asked it a question in plain text, and it did all the work on the back end to give you an answer. So we have a challenge, which I've kind of laid out a bit, which is delivering this promise of efficient network with high uptime, which is in the face of increasing complexity from multiple cloud solutions or locations, rise in automated and more intelligent cybercrime. That's something I haven't really talked about a lot because it's a huge subject. But as much as everyone is putting AI and machine learning into their platforms, so are cyber criminals. They're scraping your data from LinkedIn, Facebook, targeting you with social engineering. They're impersonating you. They're also doing more automated attacks on your computer and using identity theft to get in. So that's happening as well, and the network can help to protect you from that. We have an increased data volume and workload size due to the rise of automation. I've talked about that quite a bit. And we also have this idea of regulatory crackdown and collection and use of consumer data. So the best way, in my opinion anyway, as a network analyst, to track and figure out where all this data is going is to ask the network to tell you what's happening with it and where it's going. So, it will not be too long in the future that you are expected to give a good report of your customer data, not only where it was stored, how it's stored, but also how it transited, because it can be at risk during transit. And if the government asks you, okay, well, you've got this data, and how did you transfer it from where you collected it to how you stored it? I wonder how many people can answer that question, to a regulatory degree. So the solution is obviously AI. What that's going to look like, firstly, the idea of self-healing networks. Lots of the problems that go wrong on networks are small things that can be addressed by automated processes. We also have capabilities for detecting and preventing, repelling ongoing cyber attacks, which can extend their protection to home devices through on-device clients, remote devices through the same, premises and cloud assets. Cloud security is very much a growing area and topic for people. This idea of prioritization of workloads is one thing I really need to emphasize, because I do think we are going to get to a point where you may finish working on a task and you may have to tell the network how important it is before you finish up for the day. And if it's not urgent, you might not get the results until the next morning, but do you mind, right? So the scenario I envision with AI and this network prioritization thing is that you've put together a massive document that tells an AI program exactly what you want to build, we'll say, a new marketing campaign. And it features images and videos and lots of text. And you bundle it all together. And you don't actually need that back for about 12 or 13 hours, because you're working on it at, say, 1 o'clock in the afternoon. So if you hit send right now, it's going to consume all the bandwidth at your organization to get this package together and send it across. Or you tell your system, actually, it's not that important. And at 7 o'clock, when the network is completely empty because everyone has left your office, it bundles it together, sends it over, and you get it back the same day or the next day, the next morning when you come in, because it just gets processed overnight. And that is kind of how I think a lot of companies are going to have to adjust to all of these systems we talk about, AI, machine learning, to deal with that influx of data that they are creating. And then, of course, there's this idea that we can track and store and protect customer data just by understanding its journey and whether it was interfered with or intercepted at any point. And that's going to be quite important too. So, some conclusions to take away with us, because I think that's kind of a good point to end any speech on, is what do I have to think about and what do I have to do about it? Well, if you're in a network business, there are some good questions there. I think the question of how much energy does your network use and what sort of efficiency and prioritization and things like that can you put in that will actually save you energy in terms of the cloud usage and things like that. What business processes do you need to be aware of that your customers are trying to embrace and building on? Because the difference between non-AI and AI in terms of the amount of data required and the amount of data generated is quite large. So if you know that your favorite customer is starting to build a huge AI platform that's going to require tons and tons of data, you have an opportunity actually to upsell them on access. But you also, I think, have a responsibility to figure out how they're going to deal with all of that from a networking perspective. And then, of course, we have what is the ratio of urgent to non-urgent traffic at your customers. So can you help them understand how much traffic they actually need to deal with at a specific time and how much they can just wait for until later? For people who are selling a solution, what does it compete with? You know, what are the biggest network hogs at the company that you're working with? So that'll just help you get ahead of any potential problems. How much data does that AI solution that you keep developing, use? What problems could that cause? And then also, what sort of analytics does your solution make, and how does that impact sort of your development in terms of where does that analytics need to go? So we did a study, I think it was last year, for a big UCaaS provider who was trying to figure out where their data goes. So they generate all this analytic data from their platform, and they were like, what do people actually put it into? And they were quite surprised because a lot of the data actually ended up going into SEIM and security and company productivity, right? In that rough order. Because their actual data on how their platform was interacting and where the clients were talking to each other ended up going into security analytics and productivity analytics, not necessarily just staying in the platform. So, I mean, it's my belief that as the network gets more complex and the demands on it get more aggressive, that more analytics is going to need to come out of solutions like UCaaS, which is going to tell the network, the cloud, what is expected of it, as things go on. And that, will apply to everything. I mean, if you're going to transcribe and analyze audio logs from call recording and things like that, that is not an insignificant task when it comes to the network. So those things need to be considered. So my final slide, just as one thought, is that we've had this idea for quite a long time that a network manager is going to come in, he's going to build your network to match your desires, but it's going to work the way it works, and you kind of have to work around that. But we're reaching a point where networks are getting smarter, they're getting more responsive. And due to that, you can build a network that will take the shape of the business and the demands that are placed on it. But it has, we're getting to that point. It has current limitations, and we need to be aware of those until we get to that point. But in the very near future, the network of the future is going to take the shape of the business that it actually runs into automatically, smartly, and it's going to adapt to it. But it kind of needs fuel for that fire, which is kind of where all of solution providers fit in, because data is the tool that you have to make sure that it provides you with the best service possible. Anyway, that's the thought I'm going to leave you with. It is break time now, so thank you all for listening. If you have any questions, obviously you can grab me. That's my email address on the screen. And yeah, enjoy your coffee break.